Hi there! Welcome to the video on how to use implicit differentiation to find dy dx when I have a mathematical relation where the variables are mixed together and one's not sorted out on one side of the equal sign. Well, we can still find the derivative without having to go through and trying to solve it by this implicit differentiation. Here, our mathematical relation is the cosine of xy is equal to -1/2 plus e to the y. Now, when we are using implicit differentiation, it's really important to look at what they're asking you to find. When we are asked to find the derivative, we want to know that what's in our numerator, dy, that's telling me that y is the dependent variable, and the denominator tells me the variable x is the independent variable. So it's very important to pay attention to that so that you know the roles that they play. Now, implicit differentiation, we need to be careful as we go through this to use our derivative rules that we've already learned. And when we are differentiating the independent variable, here the x, that we will just go ahead with our rules. We don't need to do any extra factor there. But when we are differentiating and the process involves doing that on the dependent variable, we don't know what the dependent variable is equal to in terms of the independent variable. So we need to use the chain rule, which is to also multiply by the notation of the dy dx. So let's get started and see how that plays out. So on the left-hand side of the equal sign, I have the cosine of the angle xy. Now remember, the derivative of cosine of an angle is negative sine the angle times the derivative of the angle. Now the derivative of xy is the derivative of a product. So I'm going to need to apply the product rule when I'm differentiating that inside product. So remember, that's the derivative of the first factor. The derivative of x is 1, and it's the x variable, times the second factor unchanged, plus the first factor times the derivative of the second factor. Well, the second factor here is the letter y. The derivative of y is 1, but it's the dependent variable. So by the chain rule, I also have to multiply by dy dx. And this is equal to, on the right-hand side, the first term is just a constant, just a number. The derivative of a number is 0, and then plus the derivative of e to the y. Well, the derivative of e to the power is e to the power times the derivative of the power, and the derivative of y is 1, but it's the dependent variable, so I have to multiply by dy dx. Now let's just rewrite that so it's a little bit more manageable to look at. So I have negative sine of xy times y plus x dy dx is equal to e to the y dy dx. Next, what we need to do is to remove our parentheses that we can and sort all the terms with the dy dx on one side of the equation and all the terms without the dy dx on the other side. So I have negative sine xy times y. That's a negative y sine of xy. And then negative sine of xy times x dy dx. Well, negative times positive is a negative. X sine of xy times dy dx is equal to e to the y dy dx. Now, when I look at these terms, the first term does not have a dy dx in it. The second term does have a dy dx, and then I have my equal sign, and then on the right hand side I also have a dy dx. I want all the dy dx terms on the same side of the equal sign. So we are going to add this x sine of xy dy dx to both sides. So I have negative y sine of xy is equal to e to the y dy dx plus x sine of xy dy dx. And had there been any terms on the right that didn't have the dy dx, I would have moved those over to the left. Now what we've done by this is we've forced a common factor of dy dx in each of the terms on the right hand side. So we are going to factor the dy dx out of the terms on the right hand side. And we're going to factor it out the back. So we have e to the y plus x sine of xy and then dy dx. And then to solve for dy dx, divide both sides by that which is multiplied to it. So we're going to divide both sides by the e to the y plus x sine of xy. And so our final result is that dy dx is equal to negative y sine of xy divided by e to the y plus x sine of xy. And that is how you use implicit differentiation to find dy dx for cosine of xy is equal to negative 1/2 plus e to the y.